Hello, and welcome to a video on surd equations brought to you by the Answer series. I want to start off with an important concept. If I give you the following 4 examples to solve for x, we need to have a look very carefully and see what the difference is with each of them. In the first one, I've given you x squared is equal to 9. Well, if you think what times itself is equal to 9, your answer could be plus or minus 3. So if x squared is equal to 9, then x is equal to plus or minus 3. However, if you are given it in the form x equals root 9, by definition, that square root is positive only. So if you're given that x is equal to root 9, then x is 3 only. So have a good look between these two. If x squared equals 9, then x is plus or minus 3. If x is equal to root 9, then x is 3 only. If I give you x is equal to minus root 9, then x is equal to minus 3. And if I give you that x is equal to plus or minus root 9, then x could be plus or minus 3. So if you're given it with a square root, just watch very carefully what sign is in front of the square root. Example number 1. I've got 2 examples here that I want you to solve for x. So pause the video, try these, and then we'll look at them together. In the first example, what I'm going to do to get rid of the square root is I'm going to square both sides. When I square the square root of x minus 4, I get x minus 4 because a square root and a square are opposite operations. 5 squared is 25, so x is equal to 29. If I check back, in place of x put 29, 29 minus 4 is 25, and the square root of 25 is 5. In the second example, be very, very careful, because remember what we said, if they've given it to you as a square root, it is positive only. Can a positive square root equal minus 5? No, it can't, because this side has to be positive. So this one, there is no solution. Now, I know you can square both sides and you'll get an answer, but when you substitute it back in, it won't work. So there's no point doing that, because you know that this is positive on the left, on the right is negative, so they cannot be equal. I've got another 2 examples here for you. I want you to try these 2, so pause the video and then we'll do them together. In the first example, you're going to square both sides of the equation. And remember we said if you've got a square root squared, you're just left with what's underneath equals x squared. That's a quadratic equation, so write it in standard form, factorize, and you get your 2 answers. But now what we have to do in problems like these is we have to check our answers back. If x is minus 2, in place of x on the left-hand side, I put minus 2, and I get 2 as an answer. In place of x on the right-hand side, I put minus 2, and I get minus 2 as an answer. The left-hand side and the right-hand side are not equal, which means x cannot be equal to minus 2. What about if x is equal to 1? Well, substitute in place of x1 on the left-hand side, and you get your answer. Put 1 in place of x on the right-hand side, and you'll notice the left-hand side and the right-hand side are equal, which means that x equals 1 is an answer. So I get 2 answers from my quadratic equation, one of which doesn't work, and the other does. Now, why is that true? Well, if I were to think of 2 separate graphs, the graph of y equals root 2 minus x looks like that. Remember we said that a root is positive only. So the range of this graph is y greater than or equal to 0. So my graph looks like that. The graph of y equals x looks like that. How many times do they cut each other? They cut each other once, there. And that is when x is equal to 1. So where is this other solution, the minus 2? Well, if this parabola had gone on the other side as well, there would be the other solution. So there would be the minus 2. But that is not valid because the range of this graph has got to be y greater than or equal to 0. In other words, the parabola doesn't exist below, but you can see where that answer comes from and why we have to reject it. In the next example, I do exactly the same thing. I square both sides, and I set up my quadratic equation, and I solve for x. Substitute x equals 0 into the original equation, and you get the left-hand side and the right-hand side. You will notice my two answers are not equal. So x equals 0 has to be discarded as one of the solutions. If I substitute x equals 3, the left-hand side and the right-hand side both give me the same value, which means x equals 3 is a solution. And again, I've shown you the graphs. So there's the graph of y equals root x plus 1, and there's the graph of y equals x minus 1. They have one solution to where they are equal. Where is the other solution? The other solution is there. And we have to discard that one because the range of that graph is greater than or equal to 0 only. In the next example, you're going to do the same thing, except before you square both sides, you need to isolate the square root. So the first thing you need to do is put the square root on one side and everything else on the other side. So pause the video, try these two, and then we'll look at them together. The first thing I've done is I've taken 3 across to the other side. I've then squared both sides, set up the quadratic equation, which I've factorized, and I've got my two answers. Again, check. If x equals 5, the left and the right-hand sides are equal, so that is a solution. If x equals 2, the left and the right-hand sides are not equal, so I need to eliminate that. And again, there's the graph with the solution there, and the invalid solution, of course, is there. In 3.2, first thing I do is take the x across, square both sides, set up the quadratic, and I get my values of x. If I check x equals 10, the two values are different, so I need to eliminate that. If I check x equals 2, the two values are the same, so x equals 2 is a solution. And again, there are the graphs for you to see. I have two final examples for you. I want you to try these two, so pause the video and then we'll look at them together. Now these two examples give me something very interesting here. In all the examples I've done before, I've got two answers from my quadratic equation. One of them works and the other one doesn't. So what happens in these two examples? Square both sides, and I get that. Well, in the second example, when I square both sides, I get exactly the same thing. So you'll notice when you square that, or when you square that, you get exactly the same. Set up the quadratic equation, which is exactly the same, and you're getting two solutions, x equals 34 and x equals minus 1. In 4.1, if I substitute x equals 34 into the original equation, it works. If I substitute x equals minus 1 into the original equation, it also works. In 4.2, if I substitute these solutions into this original equation, neither of them works. So in 4.1, I have two solutions. In 4.2, I have no solutions. So let's have a look and see what's happening. The graph of y equals root x plus 2 looks like that. The red straight line is 4.1. you will notice that that cuts twice. The blue straight line is 4.2. You will notice that that never cuts my graph. So often we get two solutions, one of which works and the other doesn't. However, there might be occasions when both work, and there might be occasions when neither works.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.